Hey folks, so this is the lesson video for section 11.5. I've already given you a notes video and it was really short because all I did was give you the formula. And so you can see de Moivre's theorem written in front of you. And you'll notice that de Moivre's theorem is used when I take a vector and I raise it to a power. So take a look at example number 1. You see how I have a vector here and it's all being raised to the 4th power. So we'll do what de Moivre's theorem says. The first thing that you'll do is your radius is raised to that power. And then you're going to take your theta and multiply by the power. So my original 135 degrees is being multiplied by the 4. That is the value of my power. And so 2 to the 4th power is 16. 135 times 4 is 540. Now, because this is outside of the unit circle, we'll want to get the coterminal angle here. So I'll leave my 16 alone. 540, if you subtract out a whole entire circle, is the same thing as 180 degrees. And so I know that on my unit circle, that's going to be at the leftmost spot. Let's go back and read the directions. The directions told me to write in rectangular form. If I were told to write in polar form, I would be done at this point. But I need to simply simplify. So leave your 16 alone. The cosine at 180 is -1. And the sine at 180 is 0. Distribute your 16. And you're going to have -16 plus 0i. A radian example. All right, so once again, take your radius, raise it to the power. And then you're going to take your theta, 3 pi over 4, and multiply by your power. Now, what I did here was I did a bit of canceling. And so I canceled a 2 out of the 4 and the 6 so that I could multiply my fractions a little easier without large numbers. 3 to the 6th power is 729. And then when I clean up my theta, I'm going to get a 9 pi on top and a 2 on bottom. So I've got 729 cis. Now 9 pi over 2, and I didn't draw a unit circle here, but 9 pi over 2 is not in the unit circle. And so 9 pi over 2, if you just count, is one option. But 9 pi over 2 is at the same place as positive pi over 2. Okay, and that's a chapter 8 concept. If my directions said polar form, I would be finished, but it doesn't. It says rectangular form. So the cosine at this spot is going to be 0. The sine at this spot is 1. Distribute your radius, and you'll have 0 plus 729i. Now, number 3 is going to be the most challenging question of all in this section. And let's look at why that is. Examples number 1 and 2, you'll notice how I already knew what r's and thetas were before I tried to raise them to the power. But when you look at example 3, you don't know what your r's and thetas are. You only know what the legs are. So what you need to do in the very first step is you got to just take what's on the inside and figure out what r and theta is. Okay, so this is previous sections work here. So step number 1, let's get the r and the theta. You remember, if you know what your legs are, you want to draw it. So that's the first thing I did, is that I drew my picture. And then what I'm going to do there is use the Pythagorean theorem to be able to get my radius. And my radius ends up being 1. Hopefully that's a no-brainer to you because those are values that are right off the unit circle. Okay, but you can use the Pythagorean theorem if you didn't think of that. Then I'm going to ask myself, what's my theta? And notice that the legs are identical in this picture. So I'm dealing here with a 45 position or a pi over 4 position. My directions don't say anything about whether I should work in radians or degrees. And so what I'm going to do is I'll just go ahead and give both options here. Let me put my degree symbol. I'll give both options. You can use whichever one that you want. And I think that you're going to lean heavily towards one more than the other when we plug everything in. So then what I'm going to do is, now that I know what r and theta is, now I can go back and I can use de Moivre's theorem. So remember, de Moivre's theorem said take your radius and raise it to the power. So that's the first thing I'm going to do. My radius, which was 1, raised to my power of 8. You're going to take your theta and you're going to multiply by the power. Take your theta and multiply by the power. Well, I went ahead and I did some reducing of fractions on this. Okay, so let me go ahead and uncover that. So my radius, my new radius is just 1. When I take 7 pi times 2, I'm going to get 14 pi. 14 pi, though, is outside of the unit circle. 14 pi is the same spot as 2 pi. Cosine value at 2 pi is 1. The sign there is 0, multiplied by the 1, and you're going to get 1 plus 0i. So this then is my rectangular form. If I had been asked for polar form, this would have been my polar form answer. I do have a second YouTube video here. It's basically example number 3 worked. Several years ago I worked it. And so you can go take a look at that if you would like to. And it might be worded slightly differently, but the basic concept of the math is the same. So you can watch either one for example number 3.